Okay, now I am going to discuss about dot convention. It is one of the important topic to be known if you are studying a magnetically coupled circuit. Okay, dot convention. So it is one of the important topic or important rule you must know to identify the polarity of the mutually induced voltage. So we know that if I place two conductively coupled coil, okay, two coils in close proximity, and if I pass a current through one coil, the current and which is not touching each other, okay, we have two coils, okay, placed in close proximity which is not connected to each other. If current flowing in one coil will induce a voltage in the nearby coil, okay, due to the flux linkage. Okay, so the induced voltage I call it as mutually induced voltage. We are supposed to know the polarity of the mutually induced voltage. So where might be the positive sign and where might be the negative sign for the induced voltage should be known. Okay, that need to be find out. That can be done using this dot convention. So that is why I told it is very important. Okay, so just read this. If current enters the dotted terminal of one coil, the reference polarity of the mutual voltage in the second coil is positive at the dotted terminal of the second coil. Okay, if a current enters the dotted terminal of one coil, so just consider this example. The current I1 is entering the dotted terminal. Okay, the reference polarity of the mutual voltage in the second coil. So I already told that the current flowing in this coil will induce a voltage across this. Coil. Okay, the second coil, the induced mutual voltage in the second coil, the positive terminal will be at the dotted terminal. Okay, so here I told that if the current is entering, I can say it in the simple way. If current entering the dotted terminal of one coil will induce a voltage in the second coil, the positive polarity of that will be at the dotted. Okay, current entering the dotted means the generated voltage positive also will be at the dotted terminal. So negative will be at the undotted terminal. Okay. So don't ignore this positive negative. This is what I need to find out. But the dot convention says if the current is entering the dot, the induced voltage in the second coil positive will be at the dot, negative will be at the undotted. Okay, so here these two are matching, so I am writing V2 equal to mutual inductance M due to the current I1, so dI1 by dt. I have written like this. Okay, so in other way, if current leaves the dotted terminal of one coil, the reference polarity of the mutual voltage in the second coil is negative at the dotted terminal of the second coil. Okay, current leaves the dotted terminal. Okay, so in this case the current is leaving the dotted terminal. Okay, I2 is the current entering the undotted and leaving the dotted terminal. If it is leaving the dotted terminal, okay, the mutual voltage in the second coil, here in this case this is the second coil. Okay, this is my first coil and this is my second coil. This is what they meant. Okay, the induced voltage, okay, induced mutual voltage in the second coil is negative at the dotted. It is leaving the dot, so negative will be at the dot and positive will be at the undotted. Okay, so I can say the same thing in another way, like if the current is entering the undotted terminal, the induced voltage in the second coil positive will be at the undotted, negative will be at the dotted. So this is a simple way I can understand this. Okay, I hope you can understand this. The current is entering the undotted, will generate the voltage in the second coil, positive polarity will be at the undotted and negative will be at the dotted. Negative will be at the dotted terminal. So this is what your dot convention says. So using this dot convention only I am writing this. Okay, let us consider this particular circuit. The current is entering the dot, so the generated voltage positive will be at the dot, negative will be at the undotted terminal. Okay, entering the dot, so positive also. The induced voltage in the second coil, positive will be at the dot, negative will be at the undotted. So here they are asking plus minus, what is the voltage? Okay, it is just opposite to this, so that is why I am writing minus V2 equal to minus M dI1 by dt. Okay, because the generator positive is here, negative is here, but in the diagram they are asking positive here and negative here. Okay, the polarity is different, so negative sign comes. Here the current is entering the undotted, so the generator voltage positive in the second coil will be at the undotted and negative will be at the dotted. Here also polarity difference is there, so minus M dI2 by dt. Okay. So to understand this dot conversion, let us go to one example. Okay, let us consider this. Okay, I am just considering the clockwise direction, applying KVL. So it is entering negative, leaving positive, so minus V1 plus induced voltage L1 dI1 by dt. Due to the current I1 entering through flowing through the L1, I got the self-induced voltage, which is SI means self-induced, L1 dI1 by dt. There will be another voltage across the same coil due to the current I2. Here current I2 is entering the dot, so the induced voltage in this coil, the second coil, positive will be here and negative will be here. So here it is entering the dot, so generated voltage in this coil, across this coil, positive will be at the dot. Okay, it is entering the dot, so we got positive at the dot. So now compare the current direction with this induced voltage. It is obeying the passive sign convention. So how do you write the mutual induced voltage? So I need to write M. Okay, this will come due to the current I2, so dI2 by dt. So we got a plus sign because it obeys the passive sign convention. Okay, so dI2 by dt. Okay, that is due to the current I2. The positive sign here is because the current I2 is entering the dot, so generator voltage positive is here. So while checking the current directions, it is entering positive, leaving negative. So this plus minus, which is mentioned in the red, is the polarity for mutually induced voltage, and mutually induced voltage will be represented like this: M dI2 by dt. M dI2 by dt equal to 0. So we can rearrange and write like this. Next, for the loop 2, I'll clear everything. Okay. For loop 2, I need to consider the current direction of I2, which is anti-clockwise. So it will be entering negative and leaving positive for V2. So minus V2 is written, and there will be a self-induced voltage across this, that will be written as L2 dI2 by dt, which is self-induced voltage. Okay, that will be written in positive because for self-induced I will be assuming the polarity, so no issues there. But for mutually induced voltage, the polarity cannot be assumed by us. That will be based on the dots mentioned, and that will be based on the current I1 here. Here the current I1 is entering the dot, so the generated mutual voltage positive will be at the dot, negative will be at undotted terminal, and induced voltage will be M dI1 by dt. This is the induced voltage. This is due to the current I1, so dI1 by dt is written here. Okay, if I check the current direction, your current is entering positive and leaving negative, so plus M dI1 by dt. So V2 can be written as L2 dI2 by dt plus M dI1 by dt. So this is the example to understand the dot convention. Okay, and how to write the voltages for self-induced and mutually induced voltages. Okay, thank you.